day everyone. Today in this presentation we are going to solve some questions from your textbook. We will take some samples, different samples from different topics, and this presentation is for week 7. We still at electrical quantities, chapter 18, electrical quantities. So now please open your book on page 188. We will start from those questions there in this page. Question number 1, section A. What instrument is used to measure electrical current? So what we can use, or what the device can be used to measure what electrical current? As we said before, an ammeter is used for what? So ammeter, its symbol. Ammeter is used to measure what? Current, I. So instrument or device can be used to measure what? Electrical current. On the other hand, voltmeter is used to measure what? Voltage. Voltmeter is used to measure what? Voltage. Section B. How should it be connected in a circuit, or how could we connect it in the circuit? As we can see here, there are different circuits. This is the circuit in the lab, actual one, and this is for what? Just to put the symbol is for to solve questions, and this is the real one. As we can see here, a meter is connected in what? In series. A meter is connected in series with what? Or inside the circuit we have a source of a power supply or a voltage, and then we have a lamp here. So the current is start moving from positive, as we can see here, is start moving from positive to minus. So current is moving this direction. So a meter could be put anywhere here in this circuit in series with what? So this part is connected with what? With positive, and the other part of a meter is connected with what? With the minus part. So we can put it here, we can put it here, we can put it here, anywhere in the circuit. In the condition is it must be in series with what? With the source of voltage or the power supply. So how it should be connected? Should be connected or must be connected in series here in this circuit. So the positive part with the positive part, minus part of a meter must be connected to the minus part of the power supply. Section C, draw its circuit symbol. So this is the circuit symbol here, this is the symbol of a meter. So, and this is the circuit symbol of how we could connect a meter inside or with the circuit. Here we have two types of ammeter. This is the analog one, and this is the digital one. See here it's connected in series, so the positive part with the positive part, minus with the minus part. And this is what? This is a lamp. This is a lamp here. This is a digital ammeter, and this is the analog ammeter. Okay. On the same page, on question 2, we still at the same page in question 2. Question 2 says the circuit is set up in which a cell makes an electrical current flow through a lamp. Two ammeters are included, one to measure the current flowing into the lamp, and the other one is to measure the current flowing out of the lamp. So we have a circuit. One circuit is set up in which what? A cell makes an electrical. So we have what? A cell or power supply or anything. This power supply or a cell is used what? For what? To push current start moving through where? Through the circuit. So this one, it gives ability to current to start moving. So we have what here? Two ammeters are included So we have two ammeters inside this circuit. One ammeter is connected with one ammeter to measure the current flowing into the lamp. So we have current, for example, this lamp here. So this is the cell here. Current start moving when the switch is off. Start from positive to the minus. So we are going to use one ammeter to measure what? Current where moving through the lamp. So we have put one part here connected with the positive, and the other one is connected with where? With the minus one. So one ammeter could be put like this here. So this ammeter here, ammeter A, can be used to measure what? Current here, to measure the current flowing into the lamp, So we can put it like this, or we can put it where? Here. Ammeter, we can put an ammeter here. So this one is using to measure the current flowing where? Flowing into or inside. It's coming to where? To the lamp. Put it this way or this way. And the other one is used to measure the current flowing out from where? From the lamp. So we have another one here to measure the current flowing out from where? From the lamp. So put a meter here, put one here, and put another one here. Equivalent, we can put like this. They are three ways. We have three different ways, and they will give the same value of current I. So section A, draw a circuit diagram to represent this circuit. So we have what? This circuit, this power supply or cell. Current start moving from positive to minus, switch is off to let the current move. And this is a lamp. We have two ammeters here, one ammeter is here and one ammeter is here. This one is using to measure current coming to the lamp, and this one is using to measure the current out from the lamp. Both of them same. B, add an arrow to show the direction of current around the circuit. Current start moving, we put this arrow to show what? The direction of current inside the circuit. Always remember, current start from where? From positive, and keep moving until return back to where? To minus, to the minus bar. Start from positive, ending where? At the minus part. 60C, what can you say about the readings or two values on the two ammeters? What you can say here? We can say that the current is same. The current is same. It's just come from this part and out from this part. If we have, for example, 10 ampere here, so we will have the same value here is 10 ampere. So the two readings on the two ammeters are what? Same. They are same. We have the same value. Okay. Now we will move to page 190. Question number 4. Question number 4. In which direction does conventional current flow around the circuit? So we have two things inside the circuit are moving. If we have a cell or power supply or battery connected with the lamp, so we have what? The flow of what? Flow of current or conventional current. In which direction? As we said before, conventional current or the current flow where around the circuit start from positive. This one, the red one, the direction, the red one is flow of what? Of I. This is I, current I. Start from positive, ending where? In minus part. In the opposite way, in which direction do electrons flow? Electrons are moving in opposite direction of what? Of I. In opposite direction of I. So electrons start from where? From minus to positive, because they have what? Electrons, they have negative charge, are attracted with what? With the positive part. So start moving from minus to positive, minus to positive. Current, this is for electrons. Current start moving from positive to minus. So they always in opposite direction. I, current I, and electrons, they are moving in different direction or opposite direction. Okay, question number 6. How many milliamperes are there in 1 ampere? P. How many microamperes are there in 1 ampere? As we said before, 1 milliampere is equal to what? 0.001 ampere, which is equal to 10 to the power of minus 3 ampere. So 1 milliampere, or there is 10 to the power of minus 3 ampere inside 1 milliampere, and we have 10 to the power of minus 6 ampere inside 1 microampere. Or we can say that 1 milliampere is equal to 0.001 ampere. 1 microampere is equal to 0.00000603561, or equal 10 to the power of minus 6 ampere. Keep those in mind. It's very important when you're changing between milliampere to the microampere, from milli to ampere, from milliampere to ampere, or from microampere to ampere. Question number 7. In question number 7, which of the following questions shows the correct relationship between electrical units? So one of them is correct and the other one is not correct. As we said before, the equation of current is equal to current A is equal to charge by coulomb over times. So from this equation, current A, so current is equal to what? One charge on one coulomb over what? Time per second. So I is equal to Q over T. So which one the correct here? 1 ampere of current is equal to 1 coulomb charge over second, or time by second. So this is the correct one. This one, it's wrong. Why? Because it's 1 coulomb is not equal to 1 ampere over second. No, it's current times S. It's I times S, is not over. So this one is wrong and this one is correct. Question number 8. In question number 8 here, if 20 coulomb of a charge pass a point in a circuit in 1 second, so we have 20 coulombs of a charge pass a point in a circuit in 1 second, what current is flowing? From the previous equation, which is this equation, current is equal to charge over time. Current is equal to charge is, so I is equal to Q over T, which is equal to, we have a charge of what? 20 over what? 1 second. So current is equal to what? 20 ampere. 20 ampere, we can write it A or AMP, ampere. So current is 20 ampere. Just keep equation in mind, this formula. Current A, which is measured by ampere is equal to charge C, which is, or Q, which is charge current is I. Distinguish between always those A, C, S, and this equation. I is current, which is, we can read it in this way: current I, which is measured by ampere, is equal to charge C, or Q, charge Q, which is measured by coulomb, over time T, which is measured by second. So I is equal to Q over T. Q is a charge by coulomb, T is time by second, I is current measured by ampere. So it's equal to 20 over 1 second, which is 20 ampere. In question number 9, it is similar to previous one. A current of 4 ampere. So we have what? A current of 4 ampere flows around the circuit for what? 10 seconds. So we have what here? We have I, and we have what? 10 seconds T. We need to find what? Q. How much charge flows around the circuit in this time? So from this equation, charge is equal to what? Charge C is equal current times T, time. It's current times T times. So Q is equal I times T, which is equal to what? Q is equal to I equal to 4 ampere, 4 amperes times 10 seconds. It's equal to 40 what? 40 C, 40 coulombs. Okay. Okay, now we will move to page 190. Question is on page 190, question number 10. Section A. What do the letters PD stand for? PD stand for P. What meter is used to measure PD? C. Draw the symbol of this meter. As we said before, the PD is what? Actually, there is a potential difference, PD, potential difference, BD, across what? A resistor. In any circuit, there is a potential difference, which is what? Potential difference is voltage. It's voltage, V, across a resistor. So potential difference is another term of what? Of voltage. It's another term. Can say potential difference PD, or we can say what? Voltage, and is measured in what? In voltage. In voltage. So PD is stand for potential difference. Potential difference PD stand for, and meter is used to measure it is what? Is V, voltmeter. We use what? Voltmeter to measure the value of PD or V over this resistor. So the symbol, if it draw the symbol for this meter, this is the symbol for what? Voltmeter, as we said before. This is used to measure voltage. This is the symbol of a meter, which is used to measure I, current I. This one is used to measure V or PD, same, and is connected in parallel with what? This point with this point, and this point with this point. So the voltage, it gives the value or the reads of what? The voltage on what? On resistor, on the resistor only. Okay. On page 192, set of questions on page 192, question number 12. A. What is the resistance of a lamp if a current of 2 ampere flows through it when it's connected to a 12 voltage supply or power supply? So what we have here, we have what? A resistance we have a resistance R. This is R. It's very important to read the question 1, 2, 3 times until you understand the questions. Understanding the question is the half of correct answer. Understanding the question very well, it's a half or 50% from answering or to get the correct answer. So what's the resistance of a lamp if a current of 2 ampere? So we have I is equal to what? R. We need to find R, where the current I is equal to ampere, flow through it when it's connected to power supply or supply of 12. So from Ohm's law, we have V is equal to I times R. It's I times R. So we have V now, I, and we need to find R. So R is equal to what? V over I. V over I, which is equal to 12 volt over 2. It's equal to 6 ohm. 6 ohms. So the value of R is 6 ohms. Part B or section B, if PD across the lamp is increased, if BD or the voltage is increased, will the current flow increasing or decreases? Increases or decreases? As we said before, if we have, for example, like this is the circuit, and this is an R, and it's like this. If the value which makes the current flow through this, it is what? The value of V. The value of V. Power supply, cells, anything here. It's source of what? Voltage. So this source of voltage is responsible to start push what? Current moving through the circuit. Once this is increasing, if we increase the value of V, so immediately I will be increasing. If we increase the value of V, so immediately the value of I is increasing. Why? From here, I is equal to what? I is equal to V over what? R. V over R. Once you're increasing this, so immediately I will be increasing. From this equation, once you start increasing this, so the value of I will be increasing. So the resistance will be less because current is high, So if BT because the lamp is increasing, then what? I at the same time will be increased. As we have, as we mentioned it before, the greater BD in the circuit, means that if the value of BD is increasing in the circuit, so the greater the current that flows. So also keep this in mind. Also, I will be increasing. Okay, now we will move to question 13. A student cuts 2 pieces of wire, one long and one is short. We have 2 pieces of a wire, one is long and one is a short. A student cuts 2 pieces of wire, one long and one short, from what reel? So we have two parts, one is long and one is short. Section A, which piece of wire will have the greater resistance? Which piece of wire will have the greater resistance? As we mentioned in last class, we said that the longer the wire, the greater its what is its resistance. So the long one, if we have 2 wires like this is the small one, and the other one is like this. So R here, R, for example, this one is R2 and this one is R1. The resistance here, R2, is what? Greater than R2 is greater than R1. So the longer one is the greater its resistance. So the resistance of the long one is higher than the resistance of the short one. Section B, draw a circuit diagram to show how you would check your answer by measuring the resistance of the two pieces of wire. So it's easy, it just put the circuit, for example, like this, with short wire, and then put the same resistance with longer one, for example, like this, and then start. We have a source of voltage here, for example, 10, 5, whatever, and then measure what? The current. So the resistance here is less the resistance where here, because the wire is very long here and very short here. Okay, now we will move to page 193. Set of questions on page 193. Question 14. What's the value of PD is needed to make a current of 1 ampere flow through a 20 ohm resistor? So we need a value of B to push what? 1 ampere current through a 20 ohm resistor. This answer, it comes from Ohm's law. So we have I is equal V over I. So V is equal to what? V is equal to I times R. We need to find BD. BD is V. Don't be confused. BD is the same V. Potential difference is a voltage V. So what's the value of V is needed to make current of 1 ampere? So we have I here. I is equal to 1 ampere flow through 20 ohm resistor. So V is equal to what? I is what? 1 ampere times 20 ohm. So the source of voltage here, or power supply, or the cell, is what? 20 V, 20 voltage. We need 20 voltage PD to push 1 ampere through 20 ohm resistor. Okay, question number 15. Question number 15, section A. What is the resistance of a resistor? What's the value of R? The value of R here, the resistance of a resistor. If BD of 20 now is different, we have what? We need to find R. We need to find R. If we have V is equal to source of voltage or power supply is equal to 20 voltage, it causes a current of 2 ampere. I is equal to what? 2 ampere. So R is equal to what here? R is equal to V over I. V over I. V is 20 and I is 2. So the value of R is equal to 10 ohm. We need 10 ohm resistor or resistance of resistor to let 20 volt voltage across that resistance to push a current of 2 ampere to go through this value of resistor R. So that we have V, we have I, we need to find R. It's all around what? Different ways to play with what? Ohm's law. Ohm's law. Section B or part B, what BD would cause the current of 3 ampere to flow through the resistor. So we need to find BD, which is V is equal to what? I times R. V is equal I times R. So we have different questions here, or different parts. First one, we show how to find V if we have the value of I and R. Second one, we show how to find R if we have V and R. Now with the same, we need to find BD would cause the current of 3 ampere flow through the resistor on the same part of this. So the resistor, it found that it's 10, the resistor is 10 here, and the current is 3. So the value of R is what? Is 30. Is 30 volt. Is 30 volt, because the value of R is what? We find the value of R from section A is 10, but we change what? The value of I. The value of I is 3, is not 2. Since I is increasing, so what happened to V? As we said before, since it was 2, right? It was 2. Now I is, when I was 2, the voltage was what? 20. So now, if I is 3, and R is what? R is 10. So the value of B must be increased. Because I was increased. So the value of V is what? 30. Value of V here is what? 20. When we have 20, we have current of 2. When we have 30, we have current of 3. So increasing V must increase what? The value of I. On the same page, question number 17. Question number 17. We have 1 meter length of wire is found to have a resistance of 40 ohm. 1 meter of any wire, length of wire, is found to have what? A resistance of 40 ohm. Section A. What would be the resistance of a piece of the same wire if length is 2 meter? If we increase the length of this wire from 1 meter to 2 meter, so what we have here? We have here 1 meter length of wire is found to have what? The resistance of 40. 1 meter have a resistance of, for example, 40. Just for example. Okay, so what would be the resistance of a piece of the same wire of length what? 2 meter. If we increase the length of wire, so what is the value of R here? What's the value of R? As we said in previous class or presentation, the resistance of a wire is what? Proportional to what? To its length. It's proportional. The relation between the resistance and the length of wire is what? Proportional to what? To its length. So we have said before that half the length gives what? Half resistance. Half the length gives what? Half resistance. So doubling the length, if we have doubling the length here, so we have what? Double resistance. We will have double resistance. So the value of R is what? 80 ohm. 80 ohm. It comes from this this relation, or this what do you call this truth. So the resistance, keep in mind, the resistance of a wire is proportional to its length. It's proportional. Okay. So we mentioned that half the length, half the value of the length gives half resistance. So if we say double the length, we have double what? Resistance. It's same here. Okay. So we answer first part. What would be the resistance of a piece of the same wire of length 2 meter? P. We mentioned it. We mentioned it that there is a strong relation between the value of R with two things, which is what? Its length. The resistance of wire is dependent on two things. First one is what? Its length. Second one, it's what? Its cross-sectional area. We said that the conclusion that the resistance of a wire is proportional to its length, and the resistance of a wire is inversely here, opposite. It's inversely proportional to what? To its cross-sectional area. So we can say that doubling the area is different from this one, is the opposite. Doubling the area, half is what? The resistance. Here, doubling the length, doubling the resistance. Half the length, half the resistance. Doubling the area, or cross-sectional area, half is what? The resistance. So what would be the resistance of the 2 meter wire with half the cross-sectional area made of the same material? Can answer it? I will leave the answer to you. It's what now? What the value of R of 2 meter wire? 2 meters. So we have what? Doubling the area. The area, it was what? We have 1 meter. Now we have 2 meter wire with half cross-sectional area. Okay, so made of the same material. So what's the value of R here? I will leave it to you. What's the value of R? It's very easy. Just keep those in mind. Now we will move to page 195, question 18. We have a wire. In this question, just write down an equation linking between voltage. Just write down the equation. That's it. Showing the relation between what, or linking watts, voltage, and amperes. Watts, voltage, and amperes. So this is what question of what? This is the watt, this is current, this is V. So this is the equation of what? Of power. Of the power. Power is equal to what? Power is measured by watt, is equal current measured by amperes times voltage measured in V. So P is equal I times V. So watts is equal amperes times volt. So this is what equation showing the relation or linking watts with volts and amperes. So it's same if you asking you to write down the equation of the power. It's same. The power is equal current times voltage, or PD. Question 19. At 10 voltage power, we have 10 voltage power supply pushes current of 5 ampere. So we have V is equal to 10 then current is I is equal to 5 ampere sorry, through what? A resistor. So we have what? R, through a resistor R. At what rate is energy transferred to the resistor? At what rate? So what's the rate? The rate is the power. The rate is the power, because power, the definition, one definition of the power is the rate at which energy is transferred from place to place, or from one to another. Or power is what, keep in mind, the power is what is the rate at which energy transferred from place to place. So power P is equal to what? Current times phi. Current times phi. The value of I is what? 5. Write the equation, then what? Substitute the values. First write the equation. We need to find W. W is equal to I times what? V. V is what? 10. So it's equal to what? 50 watts. 50 watts. Power is equal to what? This is the power P, sorry. B is equal to what? I. B is equal to I times V. P measured with watt, I with current, V voltage. So B is equal to 5 times 10 is equal to 50 watt. So the rate of energy is transferred, or at what rate? The rate is what? 5 watt. 50 watts, sorry. Question number 20. Question number 20. It is same the previous one. We have a tropical fish tank is fitted with an electrical heater which has a power rating of 30. Power rating is what? 30. Write the equation. First step, write the equation, put down or substitute the values, and then find what? The unknown part. With the electrical heater which has a power rating of 30, the heater is connected to 12 volt supply. So BD is 12 times what? I. What current flows through the heater when it is switched on? So now we write down the equation, substitute the values, find unknown part of this equation. So I is equal to what? 30 what over 12. It is 30 over 12, so it will be by ampere. Just keep equations in mind. Try to keep all the equations in mind. Put what you have in question. Substitute the values, and then find what it's unknown inside that equation. Okay, as we did in this equation, write down the equation. In this equation, write down the equation. Equation power is equal current times V. Substitute the values. P is 30. I, we need to find I. P is 12. So it's 30 over what? 12, which is equal to 2.5 ampere. 2.5 ampere. Question number 21. How much energy is transferred by an electrical lamp in 100 seconds if a current of 0.22 ampere flows through it when it's connected to 120 supply, voltage supply? So energy transferred from equation of energy, energy transferred is equal to what? It's a power times T. It's a power times T. And power is equal to what? Current times V. So substitute P inside this equation, energy. So it's equal to what? Current times PD, or voltage times T, or time by second. So energy transferred is what? We have what? 100 seconds. So the time is what? 100 seconds. We have T. If current of 0.22 ampere, we have I. Power supply is what? Or the supply of voltage is 120. So we have all of those things, current, P, or voltage, and T. So energy transferred, or delta E, measured by joules. Delta E is equal to I V T. I times V times T, which is equal to what? 100. Okay, times 0.22 times 120. Just always keep in mind, this one must be the same, have the same what? Measured values. Ampere volt second. Okay, ampere volt second is not by, for example, milliampere volt second. No, must be the same measure. Or sometimes you find is not second here, but the time is what? Minute. In 1 minute you need to keep the same measured or the same standard for them. So the value of energy transferred is equal to 100 times 0.22 times 120, which is equal to I think 2000 seconds, 140 what? Joules. So energy transformed here, it's equal to 2640, or for simplicity we can say it's approximately 2600 joules. Okay, I think this all for today. So today, for this presentation or this class, we covered different types of questions from different topics, and we answer some questions. Please try to answer them again. Read the question 1 time, 2 times, 3 times, understanding the question. First, you need to understand to make question is very clear. Put the question, substitute the value, found a noun part of this equation if you have a question. If you have another question, try to read the listeners and make what is important, highlight the important points. And this for today. If you have any question, I am happy to answer your question. Thanks for listening, and see you next week, inshallah.